the toughest part generally for my high school students isn't solving the equation, it's getting the problem into the equation, which I think is one of the more difficult skills in math, is translating a situation into that algebraic sentence or equation. So looking at here, we have Pat, oops, come on. We have Pat and we have Stacy, and they're selling cars. It tells us that Pat sells 4 times as many as Stacy, and together they sold a total of 65. So in these types of problems, there are a couple of different types of relationships we can look for. One type of relationship is we have 2 amounts. I'm just going to call it amount A and amount B that add up to equal some sort of a total, which is actually what this type of problem, this problem is going to be. We also have one where we have the difference between amount A and amount B is given. So we're subtracting 2 amounts to get a difference. And then a third type of problem we're going to look at is where those 2 amounts just have to be equal to each other. So we have basically 2 different ways, see it, Brett? Two different ways of expressing the same amount. So in this problem, we have 2 things that are going to add up to a total. That total is 65. We just need to now figure out how do we express those 2 things. We know the first thing is Pat's sales, and the second thing is Stacy's sales. We have to figure out how to put them into symbols. So we're looking for both Pat and Stacy. We're looking for a way to express the number that they sold. We could put 2 variables. We could call them X and Y, but then we would have an equation with 2 variables in it, and we don't know how to solve an equation with 2 variables in it. On Monday, we'll take a little bit of a look at that, how we would do that. But for now, we're going to keep it in 1 variable. So we have to be able to express both the number that Pat sells and the number that Stacy sells with 1 variable. So we have to have a relationship between them. And this is what we're given in this first sentence. Pat sold 4 times as many as Stacy. So we're going to let the number that Stacy sold be X. Pat is then going to be 4 times that, or 4X. So then our total over here, Pat's sales are 4X, Stacy's sales are X. So 4X plus X equals 65, and now we can solve it. Before we actually do the solving, we have to combine what we can here. 4X and X make 5X equals 65. And then, of course, we finish that off by dividing by 5. X equals 13. Now, here's the second part we've got to be really careful about. People get really excited. They wrote the equation. They solved the equation. They must be done. But we have to make sure that we go back and answer the question. How many did each of them sell? 13 is X. That tells us how many that Stacy sold. We still need to figure out how many Pat sold. Well, Pat sold 4X, or 4 times X. So since X is 13, that'll be 4 times 13, which is 52. So Pat sold 52. And then we can double check. Does 52 and 13 add up to our total of 65? And it sure does. So that's one way of expressing, one of the ways of expressing one type of problem that we need to express in the equation. Took me a second to spit that out. Okay. Any questions on that? Okay. So now the next type of problem we're going to look at actually goes, well, let's look at the second type first. Let's say that we have Chris. And we're just going to stick with selling cars just because it's an easy way of writing it out. We could look at it as seeing patients or running labs or whatever. Chris sells 3 times as many cars as Peyton. if Chris sells 24 more cars than Peyton, once again, how many did each sell? So again, we are looking at two people, Chris and Peyton. We're trying to find the number that each of them sold. Now in this case, we don't have two values that add up to make a total. This time they subtract to give us a difference. So what we're subtracting here, Chris sold more. So it's the number Chris sold, Chris's sales, minus Peyton's sales. And that difference is given to be the 24. So again, we have to express each of them as a variable. Well, once again, we're given that simple statement. Chris sells 3 times as many as Peyton. So we let Peyton be X, the number that Peyton sold be X. Chris's then is 3 times that, or 3X. So we get 3X minus X equals 24. So we subtract 3X minus X is 2X equals 24. And of course, we just divide by 2 to solve. X equals 12. So Peyton's sales, which is X, is 12. And we do have to remember to go back and finish off. 3 times X becomes 3 times 12, or 36 is Chris's sales. Okay, so the next step then, we're going to add a layer of difficulty. It's a layer of complexity in the problem. So let's say that, come on. A urinalysis costs $50 and blood test costs $150. If 4 times as many blood tests are done, and a total cost, or the total cost, I should say, and the total cost is $6,500. How many of each test was completed? Okay, so now we're throwing an extra level of complexity here, because it's not the number of tests that are done that we're given the total of, it's the total cost we have here. So we are still looking at the urinalysis costs plus the blood test cost is going to equal some sort of a total. But we don't have, we have to figure out how to express those. The total we're given is $6,500. So we've got to figure out how we're going to express each of those costs. So over here, we're going to put down urinalysis and blood test. We're just going to say the number done is going to be the first variable we're going to try to figure out here. Well, again, we say 4 times as many blood tests are done as urinalysis. So if we let X be the number of urinalysis that were performed, 4 times that, or 4X, is going to be the number of blood tests. So that's the first thing you have to learn to pick out, is if one value is referenced off the other one. If we can express one value in terms of the other one. And that's where that 4 times as many comes in. So that the other one be X, and then this one will be 4 times that. So that's the number that are completed. We need to do now the total cost, the dollars for each. Well, the total cost, is going to be the cost per test times the number completed. So for urinalysis, it is $50 per test times the X tests that were completed. So 50 times X is just 50X. For the blood tests, those are $150 each, times, there were 4X of them that were completed. So that's 150 times 4 is 600X. So now filling in our equation here, we have the 50X for the urinalysis plus the 600X is the total cost for the blood tests. So now we add 50X plus 600X is 650X equals 6,500, and we solve our equation by dividing by 650. So X equals 10. Again, we have to make sure we go back and answer our questions. If this is 10, that means there's 10 urinalysis done. If X is 10, 4X then becomes 4 times 10, or 40. There were 40 blood tests completed. Any questions? Okay. The next strategy that we have doesn't represent one as a multiple of the other. It represents two different totals, which is going to bring us into our mixture problems. We'll start off though. Let's do the same thing. So urinalysis still costs $50, and blood test is still going to be $150. If a total of 50 tests are performed at a total cost of $6,500, once again, how many of each were performed? So again, we have two amounts that are going to add up to give us our total. It's the cost of the urinalysis plus the cost of the blood test is going to add up to our $6,500 again. The way we express those is going to be a little bit more complex this time. So the number of each that were done, we're not given that one is a multiple of the other this time. We just are given that there's 50 total tests done. I should have that right. Yep, that should work. So since there's 50 total tests done, we're just going to pick one of them, one of the numbers to be represented by X. So we're going to let X be the number of urinalyses that are done. It doesn't, we could have picked blood test and we'll get the same result. Now that we know that X is the number of urinalyses that were done, we're going to use the fact that there were 50 total tests completed to express the number of blood tests. We would subtract the number of urinalyses from 50 to get the number of blood tests. So the number of blood tests performed is just 50 minus X. So then that means the dollar amount for each, again, is just the price times the number done. So for urinalysis, that's just 50 times X, or 50X. For the blood tests, it's 150 times, well, we have 50 minus x of those that were completed. So now in our equation, we have the 50x is the amount of money from the urinalyses, plus we have 150 times 50 minus x is the blood test. That has to add up to 6,500. So now that we have parentheses, that should draw us in. And this is one of the things we covered on Wednesday, was dealing with these equations with parentheses. There's nothing we can do inside those parentheses, because 50 minus x, we cannot add or subtract unless we have the same name. So we have to see what's going to be done to the parentheses, and that's times the 150. So 150 times 50 is 7,500. 150 times negative x is negative 150x. So we still have the 50x up here. That's a positive 7,500, so I'm going to put a plus in there, equals 6,500. Any questions so far? Okay. So now we're going to combine variables. We got 50x and negative 150x makes a negative 100x plus 7,500 equals 6,500. Then we're going to subtract the 7,500. Negative 100x equals 6,500 minus 7,500 is negative 1,000. Divide by a negative 100. So x equals 10. So again, let's go back, make sure we answer our question. If x is 10, there were 10 urinalyses done. 50 minus x then is 50 minus 10, or 40 blood tests. So just a different way of approaching the exact same problem. So you can see sometimes expressing these word problems in terms of an equation can be a little tricky. So what we're going to look at is we're going to look at solution concentrations. And to understand how that works, we must look at what a solution is. The solution is generally made up of two components. There is a solvent. A solvent is usually inactive, and it is what's often in medicine what we often call a vehicle. What a vehicle is it carries the active ingredient into the patient. So it's generally like sterile water or saline solution, or sometimes just a capsule. And it is usually a liquid, and it is the larger component. There are solid solutions and gaseous solutions, but for the most part, they are liquid. The second part of the solution is the solute. And this is usually the active ingredient. For our purposes, that's going to be the medication. Or what we're going to refer to as serum. Because a serum is a generic term that gets used for the medication or a concentrated amount. And the solute is what dissolves into the solvent. So a good solution to think about, an easy one to think about, is salt water. In salt water, the water is the solvent. It's inactive, it's just water, and it's the larger portion, and of course it's liquid. The salt then is the solute. It is the ingredient that is being added, and it disappears into the water. Now, it's not necessarily terribly active, but there are some applications where a salt water solution is used. So now the amount of the active ingredient, the amount of the serum, in a solution is equal to the concentration times the volume. So if we have 200 milliliters of a 28% solution, the amount of active ingredient here, the amount of serum, the concentration is the percent written as a decimal. So 28% will be 0.28 times, well, our volume here is 200 milliliters. So 0.28 times 200 is 56. There will be 56 milliliters of that active ingredient, or the serum, in that 200 milliliters of solution. So now if we're going to mix two solutions, what's going to be combined, we don't care necessarily about the amount of water. All the solutions we're going to be looking at are going to have water as a vehicle, so the water is going to be the solvent. We don't necessarily care about the amount of the water. I mean, it's going to work out mathematically. But what we care about is the amount of that serum. So the amount of serum in solution A plus the amount of serum in solution B is going to have to equal the total amount of serum in the combined solution once we mix them together. So for example, let's say we mix 150 milliliters of 31% solution and 300 milliliters of 43% solution. What is the concentration? So what is the final concentration after we mix? Well, we're going to be looking at this right here. Amount A plus amount B has to equal the total amount. Well, the amount of serum, remember, is the concentration times the volume. So let's let amount A be the 31%. And that's 150 milliliters of that solution. Let's let solution B be the 43%. And we have 300 milliliters of that being added in. So our total amount, we don't know its concentration. That's going to be X. But the amount that we have, if we combine 150 milliliters and 300 milliliters, that is 150 plus 300 must be 450 milliliters. So the amounts must add up. The volumes must add up in this formula. So now our equation, concentration times volume, for solution A, 31% becomes 0.31 times a volume of 150 milliliters. Plus, for solution B, 43% is 0.43 times a volume of 300 milliliters equals, for our total or final mixture, we have a concentration of X times a volume of 450 milliliters. So 0.31 times 150 is what, 46.5, I believe. Yes, it is. Plus 0.43 times 300 is what, 129, I believe. Yep. Equals X times 450 is going to be just 450X. Now I do have to be a little bit careful here. I got a little sloppy with my x. I put x here. This is it's x as a decimal. This x is a percent and this is as a decimal. So as long as I keep that in mind, that when I get x, it's not really, I have to still change it into a percent for my final answer, we'll be okay. So now then down here, we can go ahead and combine. 46.5 plus 129 is what, 175.5, I believe. Equals 450x. And we're going to solve it by dividing by 450. So 175.5 divided by 450 is going to give us 0.39. So x equals 0.39. So we go up here. Remember we mentioned that this isn't really 0.39, it's 0.39 converted to a percent, which will be 39%. So our final solution after mixing these two becomes 39% solution. Well, normally we're not just going to randomly mix two amounts of two solutions together and try to figure out what the result's going to be. Normally we have a desired result in mind. We know what we want that final solution to be. So let's say that we have on hand, let's say we have 18% solution and 33% solution. And we need 23% solution. So the question I'm going to ask is how much of the 33% solution needs to be mixed with 200 milliliters of the 18% solution to create 23% solution. So again here we have to look at what we're mixing. What are those two ingredients that we are mixing? We are mixing 18% and 33% solutions. And we're going to combine them in an effort to create what we desire to make is the 23%. So we have all three of the percents here. We know 200 milliliters is the only amount we know. That describes the 18%. So there's 200 milliliters of the 18%. We're asked to find how much of the 33%. So I'm going to let the amount of the 33% be x. Now remember up here, in this example, when we found the amount of the total solution, we just added the amount of solution A plus the amount of solution B, gave us the total in our desired solution. So the same is going to happen down here. The total volume of our desired solution is going to be 200 plus x. So now we can create our equation. So for solution A, 18% becomes 0.18 times 200 milliliters. For solution B, 33% becomes 0.33 times its amount is x equals, for our desired amount, 23% is 0.23 times, that has a volume of 200 plus x. So now we have to simplify whatever we can before we start to solve. On the left side here, all we have to combine is the 0.18 times 200, which is going to give us 36. 0.33x is just 0.33x. On the right side, we have the parentheses, but there's nothing to do inside those parentheses. So we have to see what needs to be done to them, and that's going to be multiplying by the 0.23. So 0.23 times 200 is 46. 0.23 times x is 0.23x. And now it's a matter of solving the equations. So we have an x on each side, so before we really solve, we got to get rid of one of them. I'm going to get rid of the smaller one, which is the 0.23x. So that one's gone. We just have the 46 on the right side. We subtracted 0.23x from one side. We have to subtract 0.23x from the other side. That'll leave us with 0.10x. And we still have the 36 up there. And now we're down to the variable appearing once. So now we can solve this equation. What are we going to do next? Perfect. We subtract the 36. So we get 0.10x, or just 0.1x equals 10. And then divide by 0.1. Very good. So x equals 100. So now again, we have to make sure we go back and answer the question. X is 100. The units are in milliliters here. That describes the amount of the 33%. And we are asked, how much 33% solution? So that is the answer we're looking for, 100 milliliters. Most of the problems we do in the book are going to look just like this, look similar to this. But in practicality, we run into problems like this, where we don't necessarily know how much of the ingredients, we know how much we want of that final solution. So we might be told we need 360 milliliters of 17% solution. So we're going to be asked, how much 9% and how much 29% solutions should be combined. So again, we're going to combine, we're going to mix two solutions here. We're going to mix 9% with 29% in our efforts to create 17%. The amount we know is 360 milliliters of the 17% is what we desire. Now here we are not given either of the other amounts. We're only given the total. Just like we did when we were doing the urinalysis and blood test example, where we're told there was 50 total tests, we have to do the same type of thing here. We're told there's 360 total milliliters, so we just have to pick one of these two amounts to be X. I'm going to let the amount of the 29% solution be X. So then how much of the 9% solution do we have? We have our total minus the amount of the other solution. So in this case, 360 minus X. So our equation for 9%, that's going to be 0.09. Its amount is going to be 360 minus X. Plus 29% is going to be 0.29 times its amount is X, is going to equal, our result over here is going to be 17%, so 0.17 times the amount of 360 milliliters. And now we can go about solving this equation. So 0.09 times 360 is what, 32.4, I believe. Yep. 0.09 times negative x is a negative 0.09x. The positive 0.29x doesn't change. Now before I go over to the other side, I'm going to keep combining here. I can combine my negative 0.09 and my positive 0.29x. My 32.4 isn't going to change. That's going to become a positive 0.20 or just 0.2x. On the right side, 0.17 times 360. $61.2. And now the variable only appears once here now, since we've already combined it, so we can go about solving this. What's going to be our first step? Perfect. We subtract the 32.4. So we have 0.2x equals 28.8. We divide by 0.2. X equals 144. Now again, we have to make sure we answer the question. X is 144. The units being used were milliliters. But the question was how much of each? So we need the 144 for the 29%. We do 36 minus x, or 36 minus 144, which is going to be 216 milliliters for the 9%. 8 questions. I realize these are kind of complicated problems. On Monday, I plan to go over more of them. And we will go back over some of the equation stuff for you that you guys missed. Probably the biggest thing from Wednesday that you guys would have missed if the screen wasn't working would have been if we have equations like this that we need to rearrange. If we want to solve that for x, just like if there were numbers there, we would subtract b. Ax is going to equal c minus b is just c minus b. We can't combine those. And then we would divide by a to get x by itself. Well, c minus b divided by a is just c minus b over a. We might have c times p equals m times d, and you might be asked to solve that for d. So here's our d. We need to get that alone. So we have to get rid of everything else on that side of the equal sign. Here's our equal sign. We have to get rid of the m. The m is multiplying d, so we get rid of it by dividing. So it's gone. And we divide this side. C times p over m is just cp over m. You could have c times p if you wanted to, equals d. The trickier ones are when we have something like this. And I ask you to solve that for h. Well, here's h. It's on the bottom of a fraction. But if we think of this as a proportion, remember, if we had a proportion where we had 3 over x equals 15 over 25, we would solve for x by cross multiplying and dividing. 3 times 15 would be 75, or 3 times 25 would be 75 divided by 15 would give us x equals 5. We can do the same thing here, only there's no numbers to combine. H is going to equal, we cross multiply, so d times v is d times v divided by a, so divided by a. So we get that result. So we've solved it in terms of h. And that comes up a lot if we have a formula where we're going to be finding a value. If I'm going to be plugging in values for D, A, and B a lot and calculating H. It's easier if I just have it in terms of this as H equals. So I can just plug in these numbers and run it through the formula. Plug it in my calculator. Okay, so the homework that you guys had missed from Monday is in your book on page 53 and 54. And it's 1 through 15. Those are all these mixture problems. Make sure you do at least a half a dozen of them or so because they are kind of tricky. And this is when we get to Unit 2 test, the mixture problems are the ones that people struggle with the most, it seems like. Do you guys have any questions? Okay, well, you guys have a great weekend. Thank you.